this is Rakesh Naik. Today we are going to discuss about DFA, Deterministic Finite Automata. But before we start, a small information I'd like to share. In this channel we produce every video in two different languages, Hindi as well as in English. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. In our first video, we have already seen that a finite automata is a mathematical model for computation, and we can also say that it is an abstract machine that can be in exactly one finite number of states at any given time. If we want to show this in the form of a diagram, we'll be having a set of inputs. These inputs will be given at discrete instant of time, that is t1, t2 to tn, and we'll be having a set of output, that is O1, O2 to OK, and in between there are different states. Based on these inputs, the state of the automation will change. The change in the state is called a transition, and it totally determined by the presence of the state and the input. Similarly, we are having output relation. The output relation is either determined by the state or both state and input. These things already we have seen in our first video. So in order to introduce a finite automata, basically we see this kind of a diagram in any automata book. So what we are having? We are having a tape, we are having a finite controller, we are having the head of the controller, and we are having a storage. Basically a tape is nothing but a linear tape having a number of cells, and one input symbol is placed in one cell only. It means if we are having 10 input symbols, then the tape must have at least 10 cells. Next thing is about the finite control. The finite control decides the next state on receiving a particular input from the tape. It reads one symbol at a time from left to right, and then decide on receiving a symbol the system will go to which state. Next one is the head or the tape reader. The head checks only one cell at a time and can move the cell to right. In our day-to-day life, we use a pointer like our index finger. While reading a book, we point out our index finger and read. This is the same thing. We just point out where we are at present. So the work of this tape reader or the head is that it will point where it is reading right now. The next thing is about the storage. It is a temporary storage which has unlimited number of cells that it can keep. So basically we are having a linear structure. We use a linear structure because we want to read the symbols one after another in a sequence order only. That's why we say the tape is of linear nature. For example, you can see, let us say the current state is Q1 and the current symbol that the tape is reading right now is B. Then the work of finite control is to decide when the state is in Q1, on reading the input symbol B, what will be its next state. I hope you understood by now. When we are trying to represent a finite automata, basically we use two different ways to represent a finite automata. One is a transition diagram and another is a transition table. Let us see one after another. So basically for transition diagram, these are the symbols we use. A circle we use to define a state. A circle with an incoming arrow, it indicates the starting state or the initial state. Double circle represents the final state, and any arrow represents a transition from one state to other. So when we use a transition diagram to represent a finite automata, it is nothing but a directed graph associated with the finite automata. So all the vertices correspond to the state of the graph. So the state can be either a general state or intermediate state. It can be a initial state or it can be a final state. And the transition from one state to other state is represented in the form of a leveled arc. So generally we use a arrow to show transition from one state to other state. Combining all these things, we say it is a transition diagram. Let us take an example here. Here you can say Q0 is a state where only incoming arrow is there. So it is a starting state. So Q2 is a state with double circle. So it is the final state. And Q1 is any other intermediate state that is present in this particular finite automata. So basically, each state we represent with capital Q. Or here Q0, Q1, Q2 are the states which belongs to the set of states that is capital Q. So for each input symbol A which is there in sigma, we use the symbol delta to represent transition. Suppose we are at Qmth state and we are giving the input symbol A, and let us assume that we are going to another state that is Qn, then this can be represented by an arc from state Qm to Qn. So this is how we are going to show a transition diagram. Let us see how to show a transition table. So basically it is a conventional tabular representation of the function delta. And in this tabular form, the row represents the states and the column represents the input symbols. And the entry in the table shows the transition if the current state is Q, and on giving inputs A, what will be the output state? Let us see. So let us say this is a transition table. This arrow symbol to Q0 represent that this is a starting state, and a circle on Q2 represents and this is the final state. So on Q0, if input A is given, it's supposed to go to Q2. On Q0, if input B is given, it's supposed to go to state Q1. Similarly, if the state is on Q1, on giving input A, it will go to Q1, and on giving B, it will go to Q1. Similarly for Q2. So if I want to represent it, the corresponding state diagram will look like this. So Q0 is the starting state. On Q0, if I'll give input symbol A, then it will go to Q2. You can see it here. And on Q0, if I'll give input symbol B, it will go to Q1. Here it is. So like that, I can represent a transition table to a transition diagram and vice versa. Basically, a finite automata is defined into two categories. First one is deterministic finite machine or finite automata, and the second one is non-deterministic finite machine or non-deterministic finite automata. So in this video, we are going to concentrate on deterministic finite automata or DFA. Basically, a deterministic finite machine or deterministic finite automata can be constructed equivalent to any non-deterministic finite automata. We'll see how to convert it in our future videos. So a deterministic finite automata is defined by 5 tuples: Q, sigma, Q0, F and delta. Q is nothing but a finite set of states, and it should not be 5. It means if a system we are developing, at least one state must be there. Sigma, as already we have seen, it is the input alphabets. Q0 is the initial state, and Q0 must belong to the finite set of states, and F is the final state. So this F can be a subset of Q. It means either we are having a single finite set or more than one finite set. So F supposed to be subset of Q. And the transition function is nothing but Cartesian product of set of state and input symbol, and it will go to the set of state. Here under DFA, one thing that is important is here it will map to exactly one state of Q. We'll see what it is. Now let us say this is my transition diagram. And according to this transition diagram, Q contains the states, that is A, B, C here. There are 3 states. Sigma are the input symbol. So A and B are 2 input symbols we have used. Q naught is the initial state because arrow is coming to A. The final state is B because it is double circled. Delta is Cartesian product of AB Q into sigma, that is ABC into AB. Now you can see here, for every input there is exactly one state in the output. So on a state, given a input, it goes to exactly one state. So it means what? When we do the Cartesian product, we'll have these set of data, that is AA, BA, CA, then AB, BB and CB. This part is over and it's supposed to map to Q. So Q is ABC. So I want to have a mapping between this set of data and this set of data. State A, on small a, it goes to B. So AA supposed to map to B. Similarly, you are having AB supposed to map to C. So state A on input symbol B, it's supposed to go to state C. Similarly, all other input symbols I can use. The basic property of transition function, this is also very important. You can see the first property is, on any state, if I'll give the input symbol as epsilon, then the transition will be going to the same state only. And the second property, if let us say a string is there whose first character is A, then transition at a particular state on this particular string, it means it is nothing but transition of Q on A, and whatever state I'll get, again transition on W. While doing a problem, you will be able to understand this. Let us try to see what is acceptability of a string. So a string X is said to be accepted by the deterministic finite automata this when we are having a transition on Qn on input symbol X and it goes to Qn, and Qn is some final state. It means by giving some transition, if we can reach the final state, then the string is acceptable. In other way, if I want to say, if the language is accepted by M, if X is a string such that delta on Qm and X is in final state. As I have already told you, there can be more than one final state. So if it reaches any one of the final state, then we can say the string is acceptable. The language is regular set if it is accepted by some automation. We'll see when we'll discuss about regular set and regular expressions. For the time being, just you remember this statement. The accepted language is denoted by L of M. Now let us see an example. So design a DFA that accepts a string ending with 1, 1. So this is the finite automata that I'll get, which will accept all the string which ends with 1, 1. So I want to check its acceptability. The corresponding transition table is this one. It means on A, if input 1 is given, it will go to B, and on A, if input is given, it will go to A. Now let us check the string 0011 whether this string is accepted by this finite machine or not. Transition of A on the string 0011 by A is the starting state. That's why. So if we'll give first input, that is 0, then A on 0, it is going to A. So remaining 011 is left out. Again, so delta A comma 011. So the first symbol on this is 0. So delta of A comma 0 is A. So after this we'll get A. So delta of A, now the left out string is 1, 1. So the first in that is 1. So delta on 1 is B. Now we are in state B. So delta and remaining string is 1. Delta of B comma 1 is C. and C is a final state. So that's why the string 0011 is accepted. Now let us take 01100. So on this table, the starting state is A. So on A, 01100, and we have to take the first symbol. So A on 0, it is going to A. We reached at state A. The remaining string are 1100. The first symbol is 1. So A on 1, it is going to B. So we reached at state B. Now the remaining string is 100 and the first symbol is 1. So B on 1, it is going to C. So the current state is C and the remaining string is 00. And the first in the symbol is 0. So C on 0, it is going to A. And the current state is A and the remaining string is 0. A on 0, it is going to A. So it is not a final state. So A is not a final state. So that's why the string is not accepted. You can verify this with one more string, that is 0100. So this string also will not be getting accepted. By now you know what is deterministic finite automata, how to represent a deterministic finite automata, how I can say a string is acceptable or not. Now we have not yet designed any kind of DFA. So before designing DFA, these are the few points that you need to remember. The first one is analyze the set of string or analyze the language. The second point is make sure that every state is checked for the output state for every input symbol. The third statement is make sure that no state have two different outputs for a same input symbol. And the fourth statement is make sure that there is only one initial state and at least one final state. So these are the four different points that you must remember before designing any DFA. I hope you understood what is deterministic finite automata, how to represent a finite automata, and how to determine whether a string is accepted by a finite automata or not. Also we have learned what are the points that we need to remember while designing a DFA. In our next video, we will design few DFAs so that you will be able to understand it properly. If you like the video, give a thumbs up and share among your friends. See you in our next video. Till then, take care. Bye.